if you introduce a negative mass, you can build a time machine. You can, in principle, go back in time and kill your grandfather, and that will be a problem. Because if you kill your grandfather, how come you exist? So physicists don't like the idea of time machines because it leads to contradictions.
Mm-hmm.
And if you have a negative mass, you can build a time machine. How do I know that?
Let's talk about dark energy.
Okay.
So it sounds like that not long ago, we thought that there was just empty space.
Right.
There was nothing in there.
Right.
There
Nothing
was
in
nothing
there
in
because-
between the
yeah.
distance.
Right.
Between matter and matter. Now, it sounds like we've discovered that there actually is a lot of matter. And is it energy?
Well, mass and energy
In
are the
between.
same, according to Einstein. He basically had this insight that energy equals mass times the speed of light squared, E equal mc squared. And that was demonstrated with atomic bomb, like a small fraction of mass was converted to a huge amount of energy. And that's how the sun shines. It burns, it fuses hydrogen atoms and makes heavier nuclei. And in the process of doing that, it releases energy. So the sun is losing right now 6 billion tons every second. It's losing mass. 6 billion tons every second in the form of its radiation, mostly radiation coming out, but also the solar wind. There is a wind of particles coming out, and we see it. It shows in a very colorful display in our sky. Just over the past week, there was a geomagnetic storm that showed up as the aurora. These beautiful colors are the interaction of the solar wind with the magnetic field that surrounds Earth. And it creates very energetic particles moving along the field lines, bombarding atoms like oxygen, molecular nitrogen. And these atoms or molecules get excited and they emit the blue, red, and green lights that we see in the sky as an aurora. Mm-hmm. So the sun is losing mass, but it's also losing radiation. And altogether, 6 billion tons of matter. So it's a small fraction of the mass of the sun, but mass is equivalent to energy. And the dark energy is just this constituent that fills the universe, and it makes the vacuum, so it's the same everywhere. And the only effect that it has is on gravity, because usually in any other process other than gravity, all you care about is the energy difference between different states. You transition from one state to another and you care about how much energy that requires or that releases. So if the vacuum has the same energy everywhere, you don't care about it. But gravity says, needs to know how much energy or mass there is per unit volume. And if the vacuum contributes to that, it affects the expansion of the universe. And Einstein at first introduced the vacuum in order to make the universe not expand. At the time when he came up with his theory of gravity, that was November 1915, it was not known that the universe is expanding. So Einstein said, well, it doesn't make sense that the universe started at a specific point in time. It makes more sense that the universe existed forever. So how can I keep the universe forever if I balance the attractive gravity of matter with the repulsive gravity of the vacuum? So he put exactly a perfect balance between the two, but then it was realized a decade later that in fact the universe is expanding. So Einstein regretted making that suggestion, thought that it was a mistake. As it turns out, the vacuum does have a mass density. It's just early on it was not significant at all. So the universe expanded, and then right now it's dominating. So what is it is not known. We don't know whether we can excavate it, whether we can use it, because it's negative gravity, And one thing I thought about, in 1957, there was a British physicist named Herman Bondi who realized that Einstein's gravity allows for a negative mass in principle. I mean, we know that any mass we see is positive, right? It's attractive. Gravity brings things together. But he said, what if, just like in electromagnetism, you have a positive electric charge and a negative electric charge. So in electromagnetism, positive charges repel each other, and positive and negative charges attract each other. In gravity, positive masses attract each other. But if you were to introduce a negative mass, it will repel the positive mass. So he realized that if you take a positive mass and a negative mass, put them next to each other, the positive mass will attract the negative mass towards it, and the negative mass will push the positive mass away from it. So this pair will accelerate indefinitely. It's like a rocket without a fuel. It will accelerate to the speed of light. He realized that. So if you think, oh, that's great, so maybe we can build a spaceship that has a positive mass and a negative mass. If we can take, let's say, the vacuum energy from the cosmic expansion, if you can engineer it, put it in a vessel, enhance its density, and then we'll get a negative mass. If we can do that and put it next to a positive mass, we'll have a spaceship that doesn't need any fuel and will accelerate as much as we want. The problem is that if you introduce negative masses, this is something that Bondi did not realize. If you introduce a negative mass, you can build a time machine, meaning that you can, in principle, go back in time and kill your grandfather, and that will be a problem. Because if you kill your grandfather, how come you exist? So physicists don't like the idea of time machines because it leads to contradictions. Mm-hmm. And if you have a negative mass, you can build a time machine. How do I know that? Because when you take a positive mass, like, the sun, the earth, a positive mass, you pass a light beam next to it, the light is delayed. Time is ticking more slowly near a positive mass. This was realized by a colleague of mine at Harvard named Erwin Shapiro, who is now in his 90s, but he calculated how much delay the light would suffer when it passes near a positive mass, according to Einstein's theory of gravity, and that was measured and verified. Now imagine replacing the positive mass with a negative mass. Instead of delaying the light, you will advance it. It will actually move faster. And that's a problem because once you make light move faster, you can create a time machine because you can then, in principle, visit your past. And if you don't believe that going back in time is possible, then negative masses should not exist in the universe.
How would you go back in time? I mean,
so the idea is that in principle, you can build a time machine using negative masses such that you go next to the negative mass and you come back to your source at an earlier time than you left your source.
Wow.
So that means that so
you'd go out and then back.
And back and you arrive before you left. And of course, it poses a problem because, as I said, you can prevent yourself from making the trip. And so then there would be a logical inconsistency. There is a lot of debate about whether moving faster than light is possible, whether going back in time is allowed. Most physicists think that it's forbidden because it leads to inconsistencies. And if that's the case, there shouldn't be any negative masses.
You're blowing my mind here, Avi.
This is a paper that I'm writing right now, by the way. It's not out yet. So I'm giving you the latest.
Very interesting. No matter where you're watching Shawn Ryan Show from, if you get anything out of this, please like, comment, subscribe, and most importantly, share this everywhere you possibly can. And if you're feeling extra generous, please leave us a review on Apple and Spotify podcasts.